Okay. Good morning to all. In our previous session, we discussed about sorting techniques. So, in sorting techniques, there are two major type of sorting techniques available. That is internal sorting, external sorting. So, what is internal sorting means? If all the data stored in primary memory and sorting is happening in place, means within the primary memory itself, it is called as internal sorting. And suppose if the data to be sorted is large number of data we need to sort. In such case, the primary memory may not be sufficient. So in such case, a part of the data from secondary storage device will be moved to main memory and the sorting will happen. Okay, so such kind of sorting is called as a external sorting. So internal sorting and external sorting. And as per our course, we are going to discuss about only two sorting techniques: bubble sort and selection sort. In selection sort, for each pass of the sorting process, we will select the smallest value and bring it to the beginning of the list. In bubble sort, the adjacent values will be compared, and each pass, the smallest value or the smallest value will be moved to the beginning of the list, or largest value will be moved to the end of the list. So this is what bubble sort. And we discussed about example programs for bubble sort, selection sort algorithms. And we discussed hash search also. Hash search using a simple modulo operation, how to store the values in array. That also we discussed in hash search example. So this is what we discussed in our previous session. So in today's session, we are going to discuss about the topic recursion. Okay, so recursion, first we will discuss about introduction, then designing a recursive algorithm, how to design a recursive algorithm, and finally we will see some examples. Okay, so next class also we will see some examples for the recursive algorithms. Okay, first, what is a recursive algorithm? If you want to perform an operation repeatedly, okay, so continuously reading values or continuously printing values or continuously performing some calculations, redundant activities. Okay, so if you want to perform a set of operations or one operation repeatedly, okay, that can be achieved in two ways. Either we can implement it using iteration, or we can go for recursion. Iteration means we have different iterative statements: for loop, while loop, do while loop. Using any one of this, we can implement the repeatedness. Otherwise, we can go for the recursive algorithm, recursive code. Okay, so what is a recursion means? Recursion is a repetitive process in which an algorithm calls itself. Okay, suppose if you are considering an algorithm as a function, okay, a function calls itself is called as a recursive function. That we already studied in our C and C++ courses. Okay, so what is recursion? Recursion is a repetitive process in which an algorithm calls itself. Okay, so this is what recursion. Okay, so the very famous example for recursion is the finding the factorial of a given number. Okay, so uh, that program, that is finding factorial, can be implemented using iterative statements, so for loop, while loop, do while loop, or we can go for the recursion also. Okay, now we will see both the methods. Okay, factorial. Okay, a factorial is a positive number. It is a product of the integral values from 1 to that particular number. Okay, so this is what a factorial. This is a repetitive process. Repeatedly, we will multiply the n with n minus 1 and again n minus 2, n minus 3 till 1. We will perform the multiplication operation. So this is the repetitive process. Okay, so the definition of repetitive process is given here in the first definition. So factorial of n equal to, if one factorial of one value is sorry, if n value is 0 means the result is 1. If n value is greater than 0 means, so n into n minus 1 into n minus 2 into till 1. Okay, so this multiplication value is the result of factorial of n. So this is definition for the iterative statement, means iterative algorithm. Okay, and recursive algorithm definition. Okay, recursive algorithm means in recursive algorithm, in the definition, we can apply the algorithm itself. So that is what a recursive algorithm. If you see here, the second definition, a repetitive algorithm uses recursion whenever the algorithm appears within the definition itself. So in the definition, again, if we are able to call the algorithm, then such kind of definitions are repetitive algorithms. See here, in the second definition, we have given n equal to 0 means the result is 1. If n is greater than 0 means the value is n into factorial of n minus 1. Okay, means if you are multiplying n with the factorial of n minus 1, then you will get the factorial for the n. Here we are calling the algorithm once again. So this kind of definition is the recursive definition. Okay, both the first one also repetitive algorithm, second one also repetitive algorithm. Okay, for the first one we are using iterative definition. The second one is a recursive definition. Okay, first we'll see this examples, then we'll come to the theoretical part of this recursion. Okay, now how this algorithm will work, the recursive algorithm, how it will work. Okay, so here if you are checking it, it is a step-by-step execution procedure for the factorial. Okay, for the recursive algorithm. Suppose if you wish to calculate factorial of 3, okay, see here in the previous definition it is given like a factorial of 3 means factorial of 3 into factorial of 3 minus 1, that is 2. Okay, see here factorial of 3 equal to 3 into factorial of 2. What is the value of factorial of 2? Again, factorial of 2 is 2 into factorial of 1. Again, factorial of 1 is 1 into factorial of 0. Okay, what is the value of factorial of 0? See here, it is given. Suppose if n value is 0 means the factorial is 1. So factorial of 0 equal to 1. Now it will go to the previous step. The factorial of 0 value will be returned to this function call. Okay, returned to this function call. Now 1 will be returned to this place. So 1 into 1. 1 into 1 is the factorial of 1 value, that is 1. Again, factorial of 1 value will be returned to the previous step. Factorial of 2. See here, 2 into 1. Factorial of 2 value is 2. Now factorial of 2 value will be returned to the previous step, that is here. Factorial of 3 equal to 3 into 2, that is 6. Okay, so if you are looking at this definition clearly, okay, there are two parts in this program. Okay, in recursive, any recursive algorithm, what is the first one means it decomposes the problem from top to bottom. Okay, so this is the topmost value that we need. Okay, from here step by step it is decomposing. Okay, it is reducing the problem size. Okay, and the second part is it is solving from the smaller part to the larger part. What is the smallest part in finding factorial? Factorial of 0 equal to 1. This is the smallest part. First solving this. After that it is solving the factorial of 1. After that it is solving the factorial of 2. After that it is solving the factorial of 3. Okay, so in any recursive solution there will be two parts. First one is reducing the problem size. Second one is solving the smallest part to the largest part, solving. Okay, so this is how we will write recursive algorithms. Now what is the advantage of going for recursion? If you are looking into this picture and the definition, it may look like very difficult to implement the recursive algorithm, but programmatically writing a recursive algorithm is very simple compared to its equivalent iterative statement. Okay, let us see how. See here, this is the iterative solution for the factorial. Okay, that is find iterative factorial. We are getting n value. What is n value? It is the number for which we need to find the factorial. Okay, and at the end of the algorithm we will find n factorial values. So setting the I value to n, setting fact equal to n. Okay, then loop, either for loop or while loop or do while loop, any loop we can use. If I less than n means set factor of n equal to factorial of n into I, increment the I value, and we are implementing the loop statement and finally returning the factorial. So this is iterative solution for finding the factorial. Okay, now let us see its equivalent recursive algorithm. Okay, see here, this is recursive algorithm. If n equal to 0 means return 1, else return n into the function call. Okay, we are again calling the function recursive factorial of n minus 1, n into n minus 1. That's it. So if you are seeing this two algorithm, the second one recursive will look like very simple. Okay, understanding the recursive algorithm is a little bit difficult. Okay, how it works, but implementing writing the recursive algorithm is very simple compared to its equivalent iterative algorithms. Okay, that is the advantage of recursive algorithm. It is much easier and elegant solution, and it offers conceptual simplicity to the creator and reader. Now, how this recursive algorithm is working? Okay, so let us trace this tracing an algorithm. Okay, so from the function call factorial of n equal to recursive factorial of 3, we need to calculate for 3. So when this particular statement is working, okay, it is creating a new function call. A new function call means whatever happened so far here, it will be saved in a memory, and from here recursive factorial of 3, a new function call will be invoked, and 3 will come as a parameter to the new algorithm. Now again 3 equal to 0, it is not correct. So the first part will not be executed, it will come to the else part. Return 3 into recursive factorial of 3 minus 1, that is 2. Okay, when this particular statement is executed, whatever happened in this algorithm up to here, it will be saved in a separate memory location, and a new function call will be invoked. Okay, that is recursive factorial of 2. See here, 2 will come as a parameter here, and again it will check 2 equal to 0, it is not correct, it will go to the else part. Return 2 into recursive factorial of 2 minus 1. 2 minus 1 is 1. A new function call will be invoked. So 1 will go to the next function call. See here, recursive factorial of 1. Okay, and 1 equals to 0. This is also not correct. So it will come to the return 1 into recursive factorial of 1 minus 1. 1 minus 1 is 0. Recursive factorial of 0. So this will create again a new function call. So 0 will come to this place. 0 equals to 0. So now 0 equals to 0, it is true. So it will return 1. So 1 will go to this place. There is 1 into 1. Okay, again this will be returned to the previous function call. 1 into 2. So 2 into 2 is 2 into 1 is 2. 2 will be forwarded here. Then 2 into 3. Okay, 6 will be finally forwarded to the result. Okay, so this is how step by step the function call will work. Okay, so this is how we need to trace the recursive algorithm. Okay, tracing recursive algorithm. Okay, and okay, now we discussed about what is the very famous factorial example, recursive algorithm example, factorial problem. We discussed the iterative part and also recursive part. Both algorithms we discussed. Okay, now generally how to create or how to design a recursive algorithm. Okay, and in any recursive algorithm there will be two parts. What is the first part means it solves the problem. Okay, and the second part it reduces the size of the problem. Okay, the first part solves the problem, and the second part it reduces the problem. Okay, and the statement that solves the problem is known as a base case. See here, base case. What is a base case means the base case always solves the means gives the solution to the recursive problem, and every recursive algorithm must have a base case. Okay, every recursive algorithm must have a base case, and the rest of the algorithm is known as a general case. Okay, rest of the algorithm is known as a general case. So in factorial example, what is a base case means factorial of 0, because when we reach factorial of 0, it gives the solution as a 1. From that only it starts solving the rest of the problem. Okay, so the base case for the factorial problem is factorial of 0 and the n into factorial of n minus 1. So that is the general case. The general case contains logic needed to reduce the size of the problem. Okay, so in any recursive algorithm there will be two parts. First part reduces the solves the part of the problem, and second part reduces the size of the problem. Okay, and the part which solves the problem is known as base case, and rest of the algorithm is known as a general case. Okay, if we take the factorial example, the factorial of 0, okay, factorial of 0 gives 1. It is a base case, and the rest of the problem, rest of the algorithm, it is n into factorial of n minus 1. That is the general case. Okay, see here. In the recursive definition, okay, so whatever the algorithm given to you, if somebody is asking you to write recursive algorithm to you, okay, you should be able to write a definition like this. Okay, in this, the first one, okay, if n equal to 0, what is its value? So this is the base case. Okay, and what is the general case? N into factorial of n minus 1. If n is greater than 0, this is the general case. So you should be able to write a definition like this. Okay, then we can implement the recursive algorithm. Okay, the design methodology, we discussed about the two important elements. Okay, then rules for designing any recursive algorithm. Okay, first we need to determine the base case, then we need to determine the general case. Once the base case and general case identified, we need to combine these two and create the algorithm. What are the rules for designing a recursive algorithm? Determine the base case, then determine the general case, combine the base case and general case, and create the algorithm. Okay, now what are the limitations of recursion or recursive algorithm? Okay, whatever the problems we are solving using the iterations, okay, we should not convert all the iterative statements or all the iterative problems into recursive problems. It is not correct. Okay, why means in recursion we are using function calls. Okay, function calls means see here, suppose from here if I am calling a function, okay, a of 10, if I am calling a function, okay, then this will go to the particular function a. Okay, and within this, if I'm again calling a function means, okay, again it will go to the separate memory location and it will start creating a memory location and start executing a. Okay, and again whatever executed so far till here, okay, it will store it in this memory space and start invoking the a function in separate memory location. Again, since it is a recursion, whatever executed so far, okay, before the function call a, okay, whatever executed, it will store it and again it will go to the next memory location. So it will keep on invoking the functions in different memory location. For each function call, a separate memory location will be created and the data will be allocated, everything will be created. Once the function call is over, okay, it will close the memory and come back to the previous memory locations function call, and that will be processed. Again that memory will be closed and it will go to the previous memory location. A function call is very costlier process. Creating the memory and destroying the memory is a very costly process. Okay, recursion, for each, in recursion we are using function calls. So function calls are memory consuming process. Okay, so we should not convert all the iterative algorithms. Okay, whatever the algorithms we are solving using for loop, while loop, do while loop, we should not try to convert all into recursive algorithms. Okay, it is not correct way. Okay, then what are the things we need to consider? Okay, we should consider whether the recursive algorithm, whatever the recursive algorithm we are writing, whether its a data structure naturally supports recursion. Okay, naturally supports recursion. In means the later part of this course, we will study about trees. Okay, traversing a tree. Okay, the tree structure is by default very much supportive to the recursive nature. Okay, so the tree operations we will implement using the recursion. That time you can understand this. The data structure what we are using, it should support the recursive nature. Okay, the second one is the algorithm should naturally suit with the recursion. Okay, so as we already discussed about the recursion definition, if the algorithm itself involved in the definition, that is n into factorial of n minus 1. So we are using the algorithm definition factorial of n minus 1 in the definition itself. Okay, if it is possible to write like that, then we can go for the recursive algorithm. Okay, and since the recursion involves function calls, okay, it is a overhead both the time and memory. Okay, and each call takes very much time to execute it. A recursive algorithm generally runs more slower than the non-recursive implementation. Okay, suppose if you are writing a factorial algorithm using for loop and also using recursion, okay, compared to the recursion, for loop will be more faster, okay, compared to the recursive equivalent. Okay, so always recursive algorithm is slower than its equivalent iterative algorithms. Okay, so it's having this much negatives, then why we need to go for recursion? Okay, if the problem what we are solving, if it is a simple, in such case we can apply the recursion. Okay, and if the recursive algorithm runs in logarithmic time, okay, if it runs in logarithmic time, then we can go for the recursion. Otherwise we should not choose the recursive algorithm, we should go for the iterative algorithm. The factorial itself, suppose if the n value, if it is a large value, okay, then it will take more time to complete the recursive factorial algorithm. If the n value is larger, then it will take more time compared to its equivalent iterative algorithm. Okay, so generally we can consider these three questions. Is the algorithm or data structure naturally suited to recursion? Is the recursive solution shorter and more understandable? Does the solution run within a acceptable time and space limits? Okay, whenever you are writing a recursive algorithm, you should ask yourself these three questions. If any of these questions the answer is no, then don't implement that recursive algorithm. Go for its equivalent iterative nature of the algorithm. Okay, that is very important. Okay, now let us take one more example. Reverse keyboard input. Okay, reverse keyboard input means whatever you are typing in the keyboard, it should be printed in reverse order. Okay, so what is do you have any solution for this? Whatever the values you are typing, it should be printed in reverse order. How you will implement? Any answer?
For we can use for I equal to n minus 1, I is greater than or equal to 0, I minus minus.
We can store it in array. Yes, we can store it in array, and then we can print from the last to beginning. Okay, so that is one general way. Without using arrays, is it possible? Yes, possible, using the recursion concept. Okay, see here in this algorithm we are trying to print the keyboard input, whatever the value we are entering, that in reverse order. How means the algorithm contains one parameter, the data. Okay, and if the data is not end of the input, let us assume the new line character /n is the end of the input. Okay, if it is not the end of the input, okay, then only if it is end of the input means we need to stop executing the algorithm. Otherwise read a new character, again call the function. Again call the function means you read one data, but you didn't printed this data. Okay, again immediately you are calling the function print reverse of data. So again it will come here, it will check whether it is the end of the input, otherwise again it will read the data. As I already told you, okay, every time you are creating a every time you are creating calling a function, suppose if it is a print, okay, print of a, okay, here a is a variable, it is a function call, it will go to a memory location. Okay, here a will be stored. Okay, suppose if a value is c, okay, and after that c you stored, but you didn't printed, again you are calling the function. Okay, so again it will go to the another memory and it will create a memory location and a value equal to, suppose if it is a t, okay, t, and the value is not yet printed, again you are calling the function. So it will go to the, again new, it will create a new memory location, a function call, because of function call, and it will read a equal to some x. Okay, and again we didn't printed the a value. Okay, suppose the end of the input is q, let us assume. So in the next function call you are giving a value as a q, a equal to q. Okay, if this is the input, okay, if this is the input means see here, if the end of the input is a q, return. Okay, means further it will not read any data, no function calls. If the end of the input, let us assume the end of the input is q. If end of the input is q, then return. So return means what? See here, if end of the input is q, it will return to this place. Here what is the value? X. Okay, x is the value. See here, after we called the print reverse of x, okay, and it started executing here. So after this print reverse, what is the data available? Print data. Okay, print data. So here, if you are printing the a value, what will be printed? X will be printed. So it will print x. Okay, after printing x, the algorithm completed. If the algorithm completed, then also it will go to the previous function call from where we invoked the print reverse. Okay, since function call is over, it will go to this step. Again, print data. Print data means it will print t. Function algorithm completed. Go to the previous and print a. What is a? B. B will be printed. Again, go to this place. Okay, so we entered btx and it will print xtb. Okay, so this is how the function will the printing the keyboard input, okay, in reverse order will work.
Sir?
Yes.
Sir, I have a doubt.
Yes.
Sir, every time it overriding the variable a, no, sir?
Yes, it is overwriting the value, but it is not overwriting. Why means whenever a function call is created, okay, that for the new function call, okay, a separate memory will be allocated, and in that memory a will be created.
So here duplicate
Okay.
a will be generated, no, sir?
It is not duplicate A. It is not duplicate A. If it is the same memory location, then in the same memory location, in A you cannot overwrite the value. Okay, if you are trying to store the different values, it will overwrite. But for each function call, it creates separate memory location. So in each memory location, a value will be there.
Okay, sir.
That's why we are saying it is a function call. A function call means for that function call, a separate memory will be created, and within the function, whatever the variables we are using, for each variable, separate memory location will be allocated. Okay, that is what you have to understand clearly. Here we are using function calls in recursive algorithm. A function calls itself. For each function call, a separate memory will be allocated. So all the different memory locations will contain all the variables that we declared in the function. Suppose if the recursive function works 5 times, so 5 memory location, in each memory location, the data A will be there. A. First time we entered B. In the second memory location A, we entered X. Third memory location A, its value we entered T. So there will be 3 memory location. In all the 3 memory location, A will be there, and A's value in all the 3 memory location is different. Okay. If you wish, we can test the program also. So this is what the program. So that same program we implemented here. See here, reverse print. Its parameter is a character value, and if it is a new line character, when you press enter, new line character will be generated. Okay, if it is a new line character, return. Else, we are reading the value and calling the function once again. Okay, function call. We are not printing, we are calling the function. Okay, and after that, we are printing the value. Let us check it how it works. Okay, see here. Now I'm entering the input. See here, I entered welcome to Sastra, and it is printed in reverse order. ARTSAS, OT, and EMOCLEW. Okay, so here I didn't use the array concept. You can implement it using arrays also. You can get the input and store it in array, and from the end of the array, you can start printing till 0th index. Okay, but here without using arrays, we are reading the character and printing it in reverse order. Okay, so this is the example. Okay, now we already discussed about whether this algorithm is suitable or correct solution. For that, we discussed 3 questions. What are the 3 questions? First question: is the algorithm or data structure naturally suited for recursion? Okay, normally reading a list value, okay, reading a list value or keyboard value and processing, it is not recursive nature, because the keyboard input we may be in need of later processing. Suppose in this algorithm itself, the reverse value, okay, or the input value, whatever we entered, if we need to do further processing, means the data is not stored in array, it is stored in single character. Okay, it is not possible to recover or reuse it. Okay, so such kind of processing is not advisable. Okay, is the algorithm or data structure naturally suited to recursion? No, it is not. The second one is the recursive solution shorter? Okay, whether this is a short and simple? Yes, it is a short and simple. Okay, we can easily understand how it works. And the third one is whether it takes less time. No, it is not taking less time. It is a linear algorithm. Linear algorithm means if the number of input is more, then the running time also more. Okay, if the number of input is less, then the running time also less. Okay, it is not logarithmic. It is not executing in the logarithmic time. So it's take this algorithm also not running in a limited time. Okay, so here for the 2 questions, the result is, the answer is no. Okay, so even though it is possible to write a simple algorithm for the keyboard input, reversing the keyboard input, we should not try to implement this algorithm. Okay, so like this, whenever you are writing an algorithm, you should ask yourself these 3 questions, and then you should implement either recursive algorithm or iterative algorithm, because at the end of the day, we need an efficient algorithm, not simple algorithm. Okay, so the algorithm should run in a limited time, and also it should take very less memory. Okay, suppose for the same keyboard input, if you start typing the keyboard input, okay, nearly 1000 characters or 2000 characters, okay, it means that 2000 function calls will be invoked. Okay, storing 2000 character in array, it is very simple and it takes less time, but storing 2000 character 2000 function calls, okay, making 2000 function calls is very much costlier than storing 2000 characters in an array. Okay, so it's better to avoid recursive algorithm for this kind of problems. Okay, the tracing is given here. Okay, so the same we trace the factorial the same way we can trace the algorithm in this slides. Okay, and we have implemented some other programs also, factorial. Okay, so factorial using the recursion, how it will work, and using the for loop, how it will work, both implemented here. Okay, and for factorial of 5, both gives the same answer. Okay, see here, recursion, if num equal to 0, return 1, else return find fact 1 of num minus 1 into num. Okay, using for loop means the for loop, fact equal to fact into I, return fact. Okay, and printing the result. Okay, and see here, this is one more example. Okay, so printing the array values using recursion. Normally, how you will print the values of array?
Loop.
Using for
We'll
loop.
take loop and
Yeah, for loop, while loop we will use. Okay, now since we are using, it is also a repetitive statement. Okay, printing the array value is a repetitive statement. Okay, so it can be implemented using recursive algorithm also. Okay, see here, we have created the recursive algorithm here. This is using for loop and this is using recursion. Okay, so what is the base case here means we have to print 0 to n values. Okay, when the index goes more than the last index, then we need to stop executing the algorithm. Okay, return. Okay, otherwise we need to print the index value and make the function call. Okay, so this is my display 2, this is my recursive algorithm. I am passing the array and the first index. What is my first index? 0, and last index, what is my last index? 9. Okay, so if first index is greater than last index, each function call I am incrementing the first index value. So 0, 1, 2, 3, 4. When it goes beyond 9, then I should stop executing the algorithm. So first greater than last means return, else print the list of first index. Okay, and call the function again, display 2 of list, the same array, and first index plus 1. So first time I am printing 0, second time I am calling 1. So 1 will go to this place and it will print 1. Then 2, 3, 4, 5. Last index I am not doing any changes. Okay. Now let us consider the output. Let us check the output. See here, for loop also gives the same output. Recursion also gives the same output. Okay, recursion also gives the same output.
Sir,
Yes.
sir, here the execution time is same, sir, for both. But sir, the execution time, sir, for the array and that recursion, there should be difference, no, sir?
Yes, sir.
Because
Actually,
one will be more efficient.
correct. When you find the difference means when you are processing more data, okay, that time only you can the difference. And also when here the important thing is a memory. Okay, memory means in for loop, okay, we are using only the I variable and incrementing the I variable. But here in this case, for loop variable is changed 10 times, but here display 2 is invoked 10 times. Invoked 10 times means every time memory is allocated, 10 times memory allocated for the function call, and 10 times it is the memory is reclaimed by the system. Okay, so again memory wise this is inefficient. This is the solution how to write a recursive algorithm or recursive program to display the array values. Okay, this is the solution, but it is not efficient solution. Suppose here if you are changing the array values, the number of elements is 1000. Okay, in such case 1000 times memory allocated for this function call and 1000 times the memory is reclaimed, cleared. Okay, it is not a efficient way. Always we have to use for loop only. Okay, but since we are studying recursive algorithms, I am explaining you the recursive version of printing the array values. Okay, the same way you can try printing it in reverse order. Okay, printing it reverse order means in this what is the change I have to do?
Print statement we can write down.
Yes, we can move the printf statement after making the function call. After making the function call. So now simply I moved the statements here. Okay. Now if you are checking, the value will be printed in reverse order. The value will be printed in the reverse order. That's it. Okay. The recursive algorithms are simple to implement, little bit difficult to understand. Okay. But all the algorithms, all the recursive algorithms, we cannot say it is a very efficient. Okay. So this is a recursive algorithm to display the array values from first index to last value. Okay. Or last index to first value. Okay. So this is a recursive algorithm. Okay. So in the next class, we'll discuss about the recursive algorithm for the finding GCD, okay, greatest common divisor, and printing the Fibonacci series, okay, and also the prefix to postfix conversion. Okay, that algorithm is a little bit confusing algorithm. Okay, that I'll try to explain. You go through the book and try to implement it. Okay, so these programs and today's PPT I will share. If you have any doubt in today's session, please post it in the chat window.